Hello, this is Claire, and we've been looking at Pythagoras, and we're going to recap from the last lesson, and I'm going to introduce another concept. So last lesson we found the length of the hypotenuse given to the length of two shorter sides. In this situation we have a right-angled triangle, and the hypotenuse is opposite the right angle, so let's call that H. It is the longest side of the right angle triangle, so it's very easy to see, and it's always opposite the right angle. The length of the other two sides are 5 metres and 2.5 metres, and we need to find the length of the hypotenuse. It doesn't really matter which we call A and B. It doesn't matter if you change over those values for A and B on the two shorter sides, but it is critical that you know which is the hypotenuse, because the hypotenuse always comes first in the equation. H squared equals, so H squared equals 5 squared plus 2.5 in brackets all squared. We use the brackets here to show that all of that decimal is squared. So 5 squared is 25 using our tables, but 2.5 might be a bit tricky. So we're going to use a calculator. Turn it on. Oh, this is a different style calculator to the last one I showed you, but the symbol for square is exactly the same. It's x squared. The square root button is again a little tick with the roof on it, and it's not a second function this time. It's actually got a button or ascribed to itself. So there's the square root button and there's the squared button. So turning it on, it's on already. So 2.5 squared and equals 6.25. So 6.25. So if we add these together, we would get 31.25. We need to find h, not h squared, so we're going to find the square root of 31.25. So going to use my calculator again, clear the screen, select the square root button. 31.25 equals, and it's 5.59. There's a whole lot more decimal places here after the 9, but we're going to round to one decimal place. So the digit after 5 is 9. If it's 5 and above, 5 or above, you round up. If it's less than 5, you drop all these digits off. So this is going to round up to 5.6. So h is approximately equal to 5.6 metres. Right, now we're looking at another situation. This time, can you see that triangle? We have the value of the hypotenuse here. This longest side length is the hypotenuse. It's right opposite the right angle, so that is the hypotenuse. We have one of the shorter side lengths at 15, and we want to find the other side length. So let's call it A. We're going to find A. Again, we can use the Pythagorean theorem here. We're just careful to make sure we write down the hypotenuse first. Now, 25 does need to be squared. Even though 25 itself is a square number, just be careful, you still need to square it. So it's 25 squared equals the sum of the squares on the two shorter sides. So it's 15 squared plus A squared. So be very careful when you write this down that you write the hypotenuse length squared first and then the equals. And now we can go ahead and write down 25 squared, which is 625, and 15 squared is 225 plus A squared. there is a pattern for the squares of number where the last digit is 5. There is a pattern, and we can explore that pattern later. Now we're going to use some algebra, and we will need to remove this 225 by subtracting 225 from both sides of the equation. So 625 minus 225 equals a squared. This will equal 400. So a squared equals 400. And 400 is a perfect square. Just in case you don't know what it is, you can use your calculator. So choose the square root button, enter 400, and equals, it's 20. You might have known that. So a equals 20. This means that 20 squared equals 400. So we have now found out that the length of A is 20 units. Notice that the hypotenuse is the longest side length. It's longer than 15 and longer than 20, and that's just a little check you can use to make sure you've been accurate. In the next tutorial, I'm going to show you how to apply some of the skills that you've learnt to practical problems. See you then.